Last week we learned letter writing. So don't forget that, how to write the letter. Last week we learned gist writing. So a long piece of writing you use to make it 1/3 and use your own language. So that's gist. So that means if you have a big amount of data or writing, you should be able to write an abstract, because abstract is in the paper, in the manuscript you write, the abstract is basically the whole story told in 200 words. So you should be able to concise your writing, make it small. So today these two we learned, and also we learned about punctuations. So letter, gist, and punctuation. This we learned last week, and we should not make any error when you are using punctuation. So what were the rules? Every time you use any punctuation like a period or a comma or a question mark or semicolon, there should be a space following it. You must hit the space bar, and there should be no space before it. So when you write I am Sur, you give a stop over here, no space. But when you start, there is a space. Don't forget this. I know if you don't practice, you will make this mistake. And this is very odd mistake, because this doesn't need any knowledge of English. This is technical. So no space before, but one space after. Now there can be several cases when you write your data. For example, the unit. So I am 70 kilogram. So 70, how to write kilogram? Not the spelling, I am talking of the symbol, kilogram, kg. And this K and G both are small. They are not capital. So there is a space. And then you write kg. But remember, this K is like small. You have to know this. For example, temperature. Temperature normally we call Kelvin. That K is capital. So room temperature is 300 base, capital K. Don't make problem over here. Sometimes you guys are using concentration. When you write concentration, 50 space millimole. So you see the milli and the mole, they are different. If you write ppm, some of you are working with ppm concentrations, same. All of them small. So sometimes you will write, I continue my experiment for so many minutes, so many hours, so many seconds. So they also have rules. Sometimes a minute is like this. Second is like small s dot. There is a confusion about hour, 1 hour, 2 hour. Some of the journals use HRS dot. However, don't forget the space. So when doing this punctuation, be very careful. No space before, one space after. So whenever there is punctuation, this rule follows. When you are using units, units must be like this. There is a space before. So the number and the unit, this is the number, this is the unit, there is a space. 300 degrees centigrade, and that C is capital. So you need to know the units and how to write it. When you write milliliter, microliter, or liter, so that's milliliter. So you might ask me, is this wrong? This is not wrong, but the only thing is the journals use this one. So always write this one. So milliliter, microliter, or just liter. So the journals use that one. And as I use the PPT, I will give you some of the exercises so you will know what is happening. And you need to be, the most important thing is, when you write, you need to be consistent. All of you know the meaning of consistent, but in technical writing, what is consistent? So you need to be consistent, means the same everywhere. If you don't know something, you are writing wrong. Please write wrong every time. It is still better than writing wrong and right, wrong and right, wrong and right. That's worse. Because in Word, after you write the whole document, 30-page document, then you see, oh, I made a mistake in this spelling. Just go find that spelling, replace other spelling. A Word can do that immediately for you. But if you have wrong spelling and right spelling, then you don't know. So to be consistent. For example, I am from India, so India was occupied by Britain, so we use British English, but many of you prefer the American English. Here is again a problem. Spellings are different in British and American English. So when we write color, we write, but probably when you write color, you are writing this. Don't mix it up in your writing. Probably you don't have this problem, but we have, because most of the journals are American, they don't accept British spelling, and we are writing in British spelling, so they keep. So don't mix them. That is the meaning of consistency. Be consistent every time. So if you are following this, that's okay. Make it this spelling every time. So if you want to write milliliter, do it milliliter every time. Don't mix up. So that is being consistent. So please remember writing a letter, writing the gist, and use of the punctuation. So we said, please don't use the semicolon, and mostly you try to use the stop, the comma, the dash, and the colon. That's, I think, is enough. Don't try to use any other punctuations. It will complicate your life. So that's what we did last time. And today we will know a little bit of the nitty-gritties of technical writing, and as I go, I will give you examples. So this one is a quote of this guy. So what he said is that these newspaper writers and technical writers, by reading their writing, you will never understand who they are. But if you are reading Shakespeare or William Wordsworth, you will immediately know from their style that this writing is from William Wordsworth or that writing is from Shakespeare. So as a technical writer, you should not have any style. That means nobody should be able to understand that this manuscript is written by you. You should not have your own style. Just make it very technical so that it can be anybody. Otherwise, you know, your manuscript end up with somebody who dislikes you. He will say, oh, reject. So don't have that. Write it as technically as possible. So talking about technical writing, it will, of course, deal with a scientific topic, science, engineering, or technology, and something that is objective is not subjective. So what is objective? Objective means you can explain it with some kind of a value, with a number. And subjective is like, you know, did you like the food? You will say, yes, yes, I like it. And she will say, no, no, I didn't like it. That's subjective. It depends on the personal. So it has to be objective in nature. And accuracy is what is required. I don't need this. You need the data and should be accurate. And objective tone, as I said. And when you write science, you are not writing your feeling. You are writing about the data. What do I mean? This is not easy to understand. This is very subjective. Today is hot. Well, it is hot for me, maybe not for you. Or maybe it's very cold for somebody living in Africa. So this is your feeling. This is not technical. So how shall we write it? Mention the temperature, okay? Let's say, is that okay? I am bringing back that picture. Today is 30 degrees centigrade. Is it technical? So we need the time. So I have to change today. So 20th September and 2022. So let's say temperature is 30 degrees centigrade. Is this complete? Exact time, okay, at 2 p.m. This is not Germany or this is not Alaska. This is Taipei. So you see what is happening. I started with this and now I am ending with, you see what is going on. So this is the problem you are going to face in your writing. So it is not your feeling that is hot. Let the readers decide if this is hot or not. So if you are from Alaska, you will say, oh, it's very hot. If you are from somewhere in the Kalahari, they will say, oh, it's very cold. Let them decide. So it's not the author's feeling. Although I say these things, you might think it's a waste of time, but it is difficult to practice in writing. It's very difficult. You need to practice, otherwise you won't get it. Next slide. Transmit technical information accurately. Anybody have any idea about accuracy? What is accurate? Precise. To be precise. Accuracy and precise is a little different. I will show you later. So what is accuracy? Okay, what is the time now? 1:45. Are you sure? Accurate. Ken, what is the time now? 1:45. Not 1:45:30. Something like that, right? So it depends on the machine you are using. But if you are using is that an Apple Watch or something, then it can be even more accurate. It can be 1:45.667 or something. That's accuracy. So it depends on which machine you are using, right? So when I say today's temperature is 30 degrees, it's based on the AC machine, the temperature that I see. That only gives an accuracy of ±1. Now is 30, the next number is 31. That's a very common AC machine that we use. What if you use a very good thermocouple? It can be 30.05. So depending on your machine. So when you say, okay, I got an image, the resolution of this image is 1 micron. Immediately people will know what kind of machine you are using. Understand? So don't forget about the machine. So when you are talking of accuracy, accuracy means to tell the number with the certain accuracy or the digits, but should depend on your machine. So what is the trouble here? You say, I weigh the sample. There is something, I weigh it, okay? I take a small mouse and the mouse is 23 grams. I weigh. So you say, I use a common balance. Now the common balance, normally the error bar is 1 gram. So you can write the weight of the mouse is 23 grams. If you say, I used a common balance and the weight of the mouse is, the reviewer will immediately charge you that you cannot have that much accuracy using a common balance. You have to use a better micro balance. Then only you can get this number. Otherwise, you cannot get. So depends on the machine that you use. You may be using OCT or you may be using MRI, right? The accuracy is very important. What kind of accuracy you are talking about? So you give a picture. What is the scale bar of that picture? And then you say, this is about 3 inch. Then I know how big is this. So accuracy is very, very important. Accuracy, a number, let's say xy point, this is the accuracy you are talking about, and this depends on the machine you are using. So you cannot put a very peculiar accuracy, for example 4-digit accuracy, when your machine cannot give it. Your machine cannot give it. So you cannot use this. Sometimes you will make a mistake. You get 4 pieces of data, 23.59, 22.68, 24.02, 23.70. And you make a mean of it. Mean means average. Something, 1, 2, 3, 4, and you divide by 4. Then you get the answer. The mean is 23.009165 something. Wow. And you write this in your manuscript. That's very, very wrong. Because the average should also be expressed in this accuracy. So that should be your answer. Because the machine you are using has 2 digits accuracy. Then you do some mathematical operation and you give a 6-digit accuracy, cannot be. So that's accuracy. Okay? You should know how accurate is that. So no style, no grace. Just clarity, precision, and organization. That's what we are looking at. Should be clear, precise, and organized. We should have sections, organized, very nicely organized. I will show you how to organize your writing. You probably know, but we will do it in a better way. Spellings must be correct. How to make sure the spelling is correct? It's very simple. If your spelling is wrong, probably your word will make it underlined, red or blue or green. Then you fix it. Okay? Punctuation must be correct. This grammar part, do it as best as you can. You don't have to be 100% okay. I am not 100% okay, because English is also my second language, not my first language. So don't think that I know a lot of English. No, I don't know. This is technical writing, not English. So just try to be as correct as possible within your limits. That's fine. Targeted. This is a big word. So target means who you are talking to. If you want to write your manuscript, you are talking to high-level scientists. So your writing should be like that. But if you are writing to your younger brother, you cannot write big equations, okay? Legendre polynomials, no, you cannot use it. Well organized, of course. Any paper that you see, applied physics letters, this is a very good journal, physics journal you see, they have sections. So that's organized and interesting. Of course, we will see how this is organized. Interesting is a subjective word. So don't bother too much about making it interesting. If you can make it, that's very good. But interesting is a very subjective thing. You try to make it as interesting as possible. Now we come to the difficult part. Use the active voice when writing. Active voice. I told you that this is not an English class. However, a little bit here and there you need to know. What is active voice? This is the active voice, and that's the passive. We cannot use the passive voice unless we are writing something that we cannot change into active. Sometimes when you are writing results, you will see that sometimes it becomes difficult to write active. However, most of the time we will write it like this. Look at the difference. Researchers in Hawaii taught dolphins to learn new behavior. And dolphins were taught by, look at this word, by researchers. So whenever you have this word, you know that this is a passive form. Whenever you have this, it's a passive form. So for example, I can give you other very easy examples. Someone stole my bike. It's pretty simple. So this is active, make it passive. My bike was stolen by someone. So it's basically changing the subject and the predicate like this. Okay? So I bring the bike over there, and that someone goes over here. Okay? These examples look very easy, but I can give you some examples which are very difficult to change. So sometimes when writing results, so you will say the size of the nanoparticle was measured by DLS. So now you have to make it active, which is not that simple sometimes. So we have to use active voice as much as possible and not use the passive voice. I will give more examples later on. As I said last time, don't try to use very elegant, decorative language. Try to use simple language. Especially if you don't know the meaning of it, don't use it. If you don't know the meaning of it, don't use it. So these are the examples. Elegant and plain. You see, the sentence is already so small in this case. And technical writing is about being concise. Write small as possible. Because a paper, for example, this applied physics letters, this is the letter. Letter means 3-page. Every paper is 3-page long, okay? 1, 2, and 3. That's it. 1 page, first page. 2 page, 3 page, finish. And that's another paper. So length limitation is a big problem. So last week we learned how to write gist. That is, whatever is the length of the writing, we make it 1/3. You need to know how to make it 1/10 or 1/20th. The whole work into the abstract is 1/20th probably. You reduce it by 20 times, then only get the abstract. That's very, very difficult, not very simple. This one, another example. Sometimes when we speak, speaking and writing is different. We make so many mistakes while speaking, nobody cares. But when you write, you should not make those mistakes, okay? Delete words and sentences or phrases that do not add to your meaning. So you will see a wordy sentence. This is a wordy and this is a concise. It is most useful to keep in mind that blah 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 refers to a spectrum of disorders. This can be easily written as this. Diabetes mellitus refers to a whole spectrum of disorders. So it is most useful to keep in mind this. This whole thing is making the sentence very wordy. Don't do it. Write a sentence which is direct. Don't decorate it. Write it direct. It is worth noting. Sometimes we write, it is worth noting that blah blah blah. No, no, no. Not required. You are wasting 4 words. It is worth noting, 4 words. Not required. Okay? The next slide is a little difficult. So we say we need to use a sentence structure which is parallel. I give this example, although this is not enough, but just gives you an idea. Please sign the proposal, comma, date it, comma, and it must be. Here is a trouble. Something is going wrong. So we correct it. Please sign the proposal, date it, and send it to me. So this part is changing the tone of the sentence. So this is called non-parallel, and this is called parallel. However, you need to have more English writing experience to get to this. I just put it because this is sometimes required. The one that I am going to give you is very, very simple, but it will tell you the idea of active and passive. Why we are doing this? I have to justify, right? Most of our writing must be in the active voice. So this is probably the most important English thing you have to know. So that's why I give you like 5 or 6 examples. So I give you some sentences which are written probably in the passive voice. I ask you to change to active voice. So look at the answer and see if you have done it correctly. If you have done it correctly, give yourself 1 point per question. If this part is okay, I move down. We don't write a very, very formal style. So normally we write in an informal style. Should make it very simple. So the idea is very simple. And you see, if you try to write formal, the same thing becomes very long. This is much shorter. We are trying to write shorter. So whatever I do, my goal of technical writing is to write minimum as possible, as small as possible. So this is smaller than this one. This is like 2.5 sentences. This is like 1.5. Prefer this one. As a rule, we don't use conjoined words. Conjoined means, you see, whereof. Basically, there are 2 words, where and of. We join them, whereof, thereby, inasmuch as. These are all conjoined words. Try to avoid them. Sometimes you will see some paper, they have used it. So you think, okay, let me use it also. But as a rule, don't try to use these words. This is probably much simpler, but these conjoined words, don't try to use it. Or use it as less as possible. Probably, I am not sure if you have heard of this word, jargon. Any of you heard of this word, jargon? Jargon means like a common technical word, which only the people in your field understand, nobody else understands. So for example, I give you one example. A pressure. We normally measure pressure in torr. Okay, torr. Okay, this is the accuracy part. So know your machine or instrument for accuracy. So this is right, this is wrong, right, wrong, right, wrong. Okay, I need to rub it off. So whenever you are writing your machine, writing something about your machine, remember this. This is accuracy. So I am talking about jargon. Jargons are words that your friends in your lab understand. Nobody else probably will understand. So what is jargon? Normally, we measure pressure. If I ask you what is the unit of pressure, there will be 3 answers from this group. Tell me, how do you measure pressure? I am not telling if it is the air pressure or a blood pressure or something. What is the unit of pressure? Atmosphere, ATM, okay. So here is the first answer, ATM. Yeah, of course, 1 atmosphere, 2 atmosphere, 3 atmosphere, but that's a very high number. Any idea? PA, Pascal. Millimeter of mercury. Millimeter of mercury. This is probably the most simple one. The millimeter of mercury, you measure your blood pressure is millimeters of mercury. So you see, pressure is the same thing, but depending on the subject, the units are changing. Can you tell me how do you measure pressure? Any unit of pressure, anything. Don't think about science, just like blood pressure or the air pressure or something. Torr. There are many actually, bar. So you see, this is what is happening. Now what's the jargon? So let me tell you, normally the people who work in vacuum, for example, I work on vacuum. So normally our pressures will be, you see what he is telling? Now you understand what's the jargon? He is telling the pressure is -2. Now who understands -2? That's a jargon. And Aaron just now said that the pressure is measured in Pascal. You said Pascal, right? Right? But now I ask him, what is the pressure we work in? He says -2. Anybody understand what is -2? Nobody, right? That's a jargon. So what he really means is, this value, 10 to the -2 torr. But he's telling -2. That's what we do. So when I talk to Aaron, I say, come on, is the pressure -6? He understands, but he will not understand. So that's a jargon. So you need to know your audience. You need to know your audience, okay? Who you are talking to. So accordingly, and if you say my blood pressure is so much torr, people will laugh at you, because blood pressure is not measured in torr. Blood pressure is measured in this unit. So this is one example of jargon. Certain group of people have some common language. So don't use jargon. So a physicist's definition of a cell, to me, I am a physicist. If you tell me a cell, the first thing I think is a solar cell. Solar cell is a device. But if you talk to a biologist and you tell him we are using a cell, he will think of a cell. They are different. So that's a jargon. Don't use jargon. Do not invent words. Use words you are sure of. Big words, of course, we don't want to use. Try using a shorter word with the same meaning. We are trying to write concise. So you see, of course, our first goal is to, if I have a group of words, let's say 3 or 4 words, and I can make it into one, very good. Even if I have one word, and I can shorten it, so 1, 2, 3, 4, 5, 6, 7 letters, I can use. That's better. The whole length of the writing comes down. So you need a little bit of vocabulary to do that. So use the word idea for concept, ease for simplify, or help for facilitate. You will find a lot of such examples, a lot of such examples, where you can use a shorter word or fewer number of words. So these kind of things we will come across in many cases. Here I give you one example. Large number of 3 words. Just use many. You make 3 words, go to 1 word. As a general rule, 4 words, go to 1 word. At this point of time, just use now. So you see, there are many ways. Redundancies. Redundancies, this word means what is not really required. It's redundant. So for example, sometimes we write personal opinion. No meaning. It's opinion. Opinion is always personal. New innovations. Both words have the same meaning. Innovation means new. So you don't have to say it is new innovation. First and foremost, same. Current status, we use it when we speak, but it is wrong. Just say status, that's fine. Status means current. Consensus of opinion, same problem. It is consensus. That means everybody agrees. Past history, this is a funny one. History is always past. And this one. So when you are writing, the trouble of this course is very easy to write this down on a PowerPoint. When you write actually, you will forget most of these things. So I need to correct again and again and again. But it's my duty to tell you that don't make these mistakes. Cliches means some word that we use often while speaking and really doesn't have any technical value. For example, this is an acid test. So acid test means a very difficult test. But when we speak, we say acid test. Don't use them. Back to square one. That means you go from equation 1, equation 3. After doing so many mathematics, you come back to equation 1. And we tend to speak that back to square one. Don't use them. These are cliches, beyond a shadow of doubt. So we are sure. We are sure. Grind to a halt, light of day. These are not allowed in technical writing. And one very interesting thing that you cannot do in technical writing is sometimes very difficult. Okay? Please remember this. You cannot use the word no. So negative you cannot write. You have to make it positive. You have to make it in a positive way. The meaning may be something. So don't use the word no. We did not observe any decrease in x. No or not cannot be said, cannot be written. It's difficult. Sometimes you see a graph that goes like this, and you want to say that, so this is x, this is y. So first it increase, then it saturate, and then it comes down. So if you want to say that we did not observe the rise over here, you have to find out a different word. So try not to use the word no. You will find it difficult, but don't use the word no. Negative writing is not allowed. You have to find a word that means the same. It did not increase. You have to use it that it decreased. It did not show the expected increase. That means it's a decrease. So use the word decrease, which means did not increase. So I cannot use the word not. So I have to use another word. The meaning remains the same. So the value of y did not increase with x, but you were expecting this. So you just say it decreased. So that I don't have to use the word not or no. So just like I say that try to use active voice. Don't use passive voice, right? You write in a positive form. But I am sure when we do the project, out of the 10 of you, 7 of you will do this mistake. You will write no, 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 not. We did not observe, we did not find. You cannot do that. No negatives. Think positive. So no cliches, no jargon, no passive voice. Cannot use. It's difficult to remember all of the rules, but when you write, you will know. You have to write. Unless you practice, you don't know. So that is the problem. That's why after 8 weeks, we are going to do the project. The same thing, overblown phrases by virtue of deemed it necessary. Sometimes we say that since our result shows this, we deemed it necessary to do one further experiment. So don't try to use this kind of words. These are called overblown phrases. Giving extra impetus on something under separate cover. I sent it separately. Just use the word separately for under separate cover. So these are the things that you cannot do in technical writing. So more or less you know the rules. Let me repeat. You have to be consistent. If you write milliliter, write milliliter always. If you write color always. Over here, I want to put an enter to go to the next line, right? So it's like I'm changing my paragraph. I'm writing something and I'm changing my paragraph. So I hit one enter here. See where I went over there, right? If this is your new paragraph, always be here. Always be here. That means you start writing from there. Most of you do will be this. You go next, and then you hit a tab, and then you start writing from here. These are very important. You think, oh, so what is the big deal? It is a big deal. Be consistent. If you are starting from here, always start from there. If you give this tab, always use this tab. So what I'm trying to tell you that each full stop, each comma, each space is so important. So what I started by telling you that if you make mistakes in grammar, is okay, somebody will fix it. But these are technical stuff. You cannot make any mistakes here. You cannot have mistakes in spelling. You cannot have mistakes in formatting. Okay, a space, a capital letter, you cannot make a mistake over there. That nobody will excuse. If your English is grammatically wrong, that's fine, no problem. But technically, you have to be correct. When? All the time. If you are using this, hit enter and tab, enter tab. If you just want to use this, just enter, no tab. Don't mix it. So be consistent. So first thing, we are being consistent and we are concise. Consistent, we are concise. As small as possible. Positive, active. What else? Accurate. And I gave examples for all. This is what we learned today. Clichés we cannot use, so that's fine. Jargons we cannot use, that's fine. And writing these bullet points or mentioning this in PowerPoint or Word is very easy. Doing it when you are writing is very difficult. So that's why I am telling you time after time that remember the rules. We will do figure designing probably next week. So let me give you a workflow of when you write your thesis or when you write your manuscript. What is the flow? Which things you need to do first, and then which things. So for a thesis or manuscript, whatever. Manuscript, thesis is basically a manuscript. The first thing you need, number one, is your figure. And figure involves design. Okay? This is very complicated. You have to be very good in this, figure design. So I will do 1 or 2 weeks for figure design. So figure design is the first thing we do. So I get a figure. The figures are normally not very simple. The figures are composite. Composite means you will have like A, B, C. So that's a figure design. You have a composite figure. So you design that figure. Second thing that you do is write the caption. This completes the figure. So now your figure is complete. So this is your step 1 to start writing, either thesis or manuscript. After you do this, number 3 is result. Remember the structure of a paper here. Look at the structure of a paper. This one is a letter. So there is a title and abstract, and here is the introduction. So result will be somewhere here, and at the end is the conclusion. However, when we do it, we start with the figure and the result. We don't start with title or introduction. We start here. Because if you have this, you can do this. If you don't have this, your writing stops. So we start with the figure design and then we write caption. This one will take a long time, so I am not doing it today. I will do this one, caption. So I will start with caption. And the caption is a very simple thing. You have to just remember what I did with my hand. That is caption. So, and then, of course, we will go for other ones, but let's see what's the caption. First, let me draw. I give you one example, then I go ahead. Very simple. What is the caption? I want to write a caption. Let's say this is figure 1. This is figure 1. Tell me the caption. How do you know it's linear? I did not draw anything. So tell me the caption. How should I write it? It's a very simple thing. This axis is x and that is y. Plot. What is a plot? But you have to think that what do you mean by a plot? So I start with a very simple one. This is simple. Variation of y with x. Sometimes we say as a function of x. This y with we say as a function of. So variation of y as a function of x. This is a simple caption, but things will go very difficult. So very simple, variation of y with x. Remember, what is this? So this is a variation of y with x. Now, so Wayne was trying to say that this is linear. Let's make it linear. The same figure, the caption is changing just because I put this line. So this is what we need to do, because this caption is mostly all of you will make a mistake with this caption. Your idea of caption is like result. That's completely wrong. So how do I write this? This is what you should write. You cannot change any word. The line joining the data points is a linear fit to the data. So you see, if you don't have the line, then it is just variation of y with x. If you have this line, then you have to add this. The line joining the data points, these are the data points, and this line joining the data points is a linear fit to the data. If it is linear, if it is not exponential, exponential, logarithmic, log, or some other equation, this line is fitted with y equal to e to the power something. However, you should write like this. Remember, you cannot change the words. You have to write it like this. So remember it. I don't have it. I forgot if I have it in the PPT. Now you may say, oh, this is very simple. This is linear. What if it is not linear? It is just like some kind of scatter. If it is just like some kind of scatter. So for example, if it is like this. So you do like this, like this. This is not linear. This is not log. This is not exponential. So how do you write it? That's another technique to write it. So you have some scattered data points and you just join them by a line. Then how do you write it? The line joining the data points is a guide to the eye only. So it doesn't have any scientific meaning. So it is just like I join them. So this is the sentence you have to use. So this is a variation of y with x. The line joining the data points is a guide to the eye only. All words need to be written, no change. So if it's a linear fit, log fit, exponential fit, use this one. If it is not, if you are just joining them like this, it is this one. If you have certain examples of this in mind, you can ask me, right? It's very simple. If you go step by step, I started with some data points. Then I joined them with line. How to write? Now I will add some more things. Let's say when you do the experiments, you don't do it once. You do it 5 times, 10 times, okay? 7 times. So you have error bars. What will you write? The same figure changing. I am making it more beautiful. The caption is changing. What will you write? I just put the error bar. So I need to write something about the error bar. Now errors are so many kinds in science. So the best one, the easiest one, I can tell you, the error bars indicate a scatter of the data over 5 measurements. That means you did 5 measurements and all the data is here, 1, 2, 3, 4, 5, somewhere. So it is a scatter in that data. This is one way of writing it. There is another way. If you look at the scatter or the error bar, you will see one thing. The data is somewhere and the mean is somewhere. So if this is the extremities of the error bar, the mean is probably here. So in that case, you say the data is presented as, this is probably what I think biology guys will do, this line. The data is presented as mean plus minus SD, where SD means standard deviation. Okay? And this is the language. You cannot change this. It has to be this. The data is presented as mean plus minus SD. So this is the mean, this is the plus SD, this is the minus SD. You cannot change the language. If you know this, you can immediately understand what is the rule of writing a caption. First rule, write what you see. Write what you see. Whatever you see, you have to write. You see the data, you have to write. You see this line, you have to write. So write what you see. See how the figure goes. I put an arrow here. If you put an arrow, you have to write about the arrow. The arrow indicates something. If you have an arrow in the figure, you have to write. The arrow indicates, this is, let's say, X or something. Whatever you see in the graph, you have to write. Whatever you see. This line, this data, the error bar, this arrow. If you put a line over like this, you have to write about the line. That this line indicates y equal to 50. So this value is above 50, those values are below 50. What you see, you write. Don't make a mistake here. This is probably where most of you will make a mistake. Whatever little thing, if you put an arrow or a line like this, or write something here, you have to mention. Write what you see. Second rule, do not write the word show or shows. This word should not come in the caption. Here also, most of you will make a mistake. Many of you will say that figure 1 shows the variation of y with x. I am telling you, don't use the word shows here. Understand? So this is basically what a figure caption is. However, you can understand sometimes your figures are not that easy. Okay? Sometimes it's a combination of data, of image, of something else. There will be complicated thing. Remember, in modern day science, there is nothing like this figure. All you have will be A, B, C, D, E, F, G, H. There is so many. And this caption becomes longer and longer and longer. So it's very difficult. Just remember this clue. Write what you see. Every little detail you see, you have to write. So now this is, I start with a very simple one. Later on, I will show you very, very complicated ones. So you got the idea? Don't write the word show unless there is an inset. Unless there is an inset. There is one exception. This is the rule. Write what you see and do not use the word show or shows, okay? So this is a general rule that you have to follow. However, there is one exception. If this figure contains an inset, this is a figure, and you can put some extra data, some extra image as inset. You can put it over here. You can put it over there. Okay? These are called inset. Most of you guys know this as insert. It is not insert. Many of you will write it. No, it is not insert. It's inset. Okay? If there is an inset, how to write? So this is figure. Let's say a figure, okay? Let's say A or something. So this is figure. Figure 1 or something is something, something. Inset shows. Now the word comes in. If there is an inset. Inset shows the image of something. Okay? So normally in this caption, the word shows cannot come unless there is an inset. This is the exception. If you have an inset, then you can write inset shows. Most of you will have complicated figures. So your figure will be like this. Let's say, okay? Then how will you write? It's very simple. Then you cannot write just inset because there are A, B, C. So you have to write inset in A shows. Write what you see. Whatever you see, you have to write. Do not write the word shows unless it has an inset. Okay? Figure design we will do. Figure design is very interesting, very funny, okay, very, very nice. It's big fun, okay? You say that you work with image. No problem. You work with image. But even if you work with image, you need to know how to make data figures. That will help you maybe when you go to a company or something. You still need to do that. Even making image is not that easy. This is a general caption. Any question on this? If not, let me give you very simple examples. Look at that. Simple, just like I put my hand. So here is something. So what is this? So this is figure 1. Photograph, this is a photograph. It's not a schematic. is not a drawing, is not a data or something. It's a photograph of a pen. What kind of a pen? Is it a ballpoint pen? No, it's a fountain pen, okay? And it is doing some signing or scribbling, okay? So photograph of a fountain pen scribbling. That's the caption. If that is so, what is this? Yeah, so it's a photograph or a schematic or a drawing? Photograph. Remember that. When you show an image, you have to tell that this is MRI or OCT or PET or CT, what? So, and what kind, okay? Remember, top view, cross-section, blah, blah. All this you have to mention. So this is a photograph of a printer. Enough? It's a color printer. You see that? Right? Remember these things. It's very easy to get lost. Okay. What is this? Oh, this is torch. When it gets dark. Yeah, something like this, pen light, torch, okay. So what is this? Is it a schematic or is it a photograph? It's a photograph, okay. Okay, I am showing easy ones. Okay, now what is this? This gets complicated. So what is this? Let's say this is a photograph, and by the look of these lines, it looks like it's a laser. If it is not a laser, the light will spread, just like the before one, this one. It will spread. It's line, that means most probably it's a laser, maybe a cheap laser, but still a laser. How will you write the caption? So photograph of, you have to bring your thinking into writing. That's where it gets difficult. So when you look at it, you say, okay, these are photographs of 3 lasers, red, green, and blue. But when you write, it is not that simple. So let's say this is figure 1. Something like this. You cannot just say it is red, green, and blue if this image is printed in black and white. Normally, when our papers get accepted, the journal asks us, do you like to pay for the color image? And we are all poor. We don't have that money. We say, no, it's only color online. In print, it is black and white. Then they say, then you have to change the caption. Then we do this. So from left to right, it's red, green, and blue. So things are getting complicated. So you need to know, write what you see, but you have to maintain the structure. So the structure needs to be maintained from left to right. Red, green, and blue is not from like right to left or top to bottom. If it is, then also you have to write. What is number 5 and what is number 6? What is this and what is that? Same machine, but different type. This is the one that we have at home. But this is not the one at home. This is the industrial, the big one. How will you write it? So this is a photograph, okay? Photograph of a vacuum cleaner. What kind? Now is the challenge that you need to know the word. What is this and what is that? This is a domestic, okay? The first one is a domestic, and the next one is an industrial. Now you see how you write it. You don't use the word vacuum cleaner 2 times. I have to be concise. So you'll think, what is this figure? This is a photograph of a domestic vacuum cleaner. If this is the same figure, A and B, I would write it photograph of is common. A domestic, comma, space, and B, an industrial vacuum cleaner. So the word vacuum cleaner comes only once. I don't use it 2. That A, photograph of a domestic vacuum cleaner, stop, B, photograph of an industrial vacuum cleaner, then it gets long. I have to make it short. So, like this. So, sometimes you need a little knowledge of vocabulary, okay, just like how to call it. But of course, things won't be difficult because you know your machines. You know how to write. These are easy ones. These are very easy ones, okay? What is this? These are all photographs. Let's say photographs of, this is a conical flask, like a cone. Conical flasks containing different color liquid. That's not enough. Then you have to write from left to right. Blue, yellow, green, red, and black. That makes it complete. Volume is also different, yeah. That you need to also see that it is from big to small. You have to write that also. If you can clearly see how much it is 200, how much is 100, 50, 25 and something, we can write it. You have to write that conical flask having volume of this, containing blue, yellow, green, red and black liquid respectively. What is this? Photograph of, most of us use this, most of us, right? What is this? It's a microscope. Is that enough? What kind of microscope? Optical, what kind? So you need to know the type. Microscopes are two types, right? One is you shine light here, you get light there. And one is you shine light here and you get the light there. So inverted, upright, you need to know. Tough, not easy. You think, oh, this is so simple. Oh, this is a photograph of a microscope. Inverted or upright. And having what kind of objectives. So these are fun. So it is like a challenge. You have to find out the details from the picture. But it is easy for you because in your thesis or in your paper, you are only going to put the figures or the machines you know. So it's very easy for you to write. For me, maybe it's a little difficult. But for you, it should be easy. So you need to know the details. So your machine, you know. Then if you put a schematic or put a picture of that. So for example, if you draw a schematic of the OCT machine you are using, you can say, oh, this part is this A and then a light goes over there. Here is the sample, which is a pig or a mouse or something, the ear or something. This is how you do it. The pictures I have put is very general, very easy. So I think maybe most of you will know. In reality, when you write your thesis or manuscript, you are using some special machines that you know. So it won't be a problem for you guys. What is this? Is this a photograph, microplate? This is a well plate. So you do the cell culture over there. This one is the easy one. What is this? How do you call this? Yes, Eppendorf or vials. But if you want to write the caption, that's not easy. So photographs of Eppendorfs containing some kind of stuff. I don't know, it's water or something. But then you have to mention that from left to right, it is A, B, and C. That is the challenge. The rest is easy. So the challenge is to how to write that this one is A, this one is B, this one is C. Okay? So that one is the challenge. Labeled as from left to right, photographs of Eppendorfs labeled A, B, and C from left to right. If you know, yeah, if you know. So in that case, yeah, that's a good question. Then you know what is in A and what is in B and what is in C. The main purpose is, so you must be thinking that, some of you may be thinking, this is not my case. I don't have figures like this. That's not the question. The question is, if I write this, and if you see this picture, any of you who doesn't know what is ABC, what is this Eppendorf, by reading this, do you understand the figure? That's the important thing. So our job is, if you understand, that's your job. I have to write the caption of any figure that is not your subject. This is not your subject, let's say. But I have to write in a way that even people from outside my subject can understand this. You need not know what is acetone, what is ethanol, what is hydrochloric acid. You need not know. But you know that A vial contains something called acetone, and that B vial contains something called this, that C vial contains this. This I understand. Even if I am a non-scientific person, I understand this. This is the job of a technical writer, to make you understand this figure independently. Independently means what? Means when you see a figure, this is a figure, you read the caption here. Only by reading this you understand this figure. No need for you to read this part. If your caption is bad, if this caption is bad, then to understand this figure you need to read. That means it's a bad technical writing. If you are a good technical writer, then this figure must be independent. That means just by looking at the figure and the caption, you should understand what this is. No need to read. This is an independent figure. That's what we are trying to make. When you make a figure, it must be independent. No matter it is in the thesis, it's in the paper, or in your seminar presentation. That figure must be independent. This is the main thing. If you know this, in your project you will score at least 85, if you can maintain this. Because I won't deduct any mark for English mistake. No, that's okay. You make mistake, I make mistake, no problem. But this needs to be independent. I look at the figure, I should understand what that is. And that doesn't matter if I understand OCT or not. You have to make your figure in a way that I understand. That's your challenge. You know that I don't know OCT, right? But you have to make it in a way that me, a semiconductor guy, should understand what OCT is just from looking at your figure. That is the challenge, and that's not easy. But if you try, I am sure we can get it. Okay, so with that I will stop today. If you have any questions, you ask me. So today we did a lot. Next week we will show figure design. That's how we start. Figure design, write the caption, complete, then start with result. Then we will go with experimental, discussion, introduction, conclusion and caption, referencing. So you have any question, ask me. Yes?
Can we write the abbreviation of left to right in L to R?
Good question. In general, I say this has to be independent. So independent means not only this L to R, but even when I write HCl, this is, some people may not know what is HCl. So you have to write hydrochloric acid. You have to write that. So the rule is no acronyms. In caption. No acronyms. If you do have to use, sometimes there are very long words that are repeated, maybe 2 or 3 times. Then you define it and then use it. Otherwise, no acronym in caption. So for example, Gordon, you cannot use, for example, this is containing photographs of vials containing UCNPs. You cannot write. Because if you write UCNP, then what is UCNP? You have to write here. Otherwise, it doesn't become independent. Then whoever reads this figure that containing UCNPs, let's say here I write UCNP, then people will say, oh, what is this UCNP? I have to go back to the text and read and understand UCNP is upconversion nanoparticles. You cannot do that. If this word appears 2 or 3 times, then you define that UCNP is upconversion nanoparticle, then you put UCNP, is okay. So it has to be independent, no acronyms. If there are long words appear 2 or 3 times, define the acronym. Define and use. What is define? Define means, like, for example, Taiwan is TW, and then use TW, like that. First define and then use. Then it will become independent. Otherwise, to understand what is UCNP, I have to go back to the text and then come back here again, which is trouble. You do the definition here, where it appears first. And L2R, of course, you have to write fully. left to right. If it appears again, if you have another figure, like next one, then you can write L to R, because I have defined it left to right. Define and use. Define and use. Otherwise, no acronyms. All longhand. You have to write longhand. So if you want to say this is OCT image, so first you have to say optical coherence tomography, bracket OCT, image of this, dot, B, OCT image, then you can do it. Then your caption will become independent. Clear? So for example, in abstract, abstract is completely separate than the main manuscript. So if you define BSA, bovine serum albumin, in the abstract, in the introduction you have to define again, because this is considered separate. Even if you have used BSA in the abstract, you still need to define it again. And what you define in the introduction, or let's say result, doesn't count when you are writing the caption. Doesn't count. You have to do it again here. Do it again, because we want to keep it independent. To understand this UCNP, I should not go back to the text and come back here. Only the figure. If somebody just gives you the figure, no text, you should be able to understand. Then you are a good technical writer. Questions?
Sir,
Yeah.
So in case in our studies, if we use solutions which is composed of 3 different chemicals with different compositions, then suppose in the introduction we label it as A, B, and C. And then in the figure captioning for the photograph, do we still have to mention that?
You still have to mention theoretically, yes. Theoretically, according to rule, you still have to mention. It can become very long. So that's the rule. Now you see that in the manuscript, it's not only a paper, it can be a review. It can be a letter. This one is a letter. Letter means very short paper. Normally it's a long paper also, or a review, which is very long. In that case, sometimes what the authors do is, they will say that the definitions of these abbreviations can be found somewhere. So they write many, many acronyms. And then at the end, they add one line. The acronyms can be found in the text. This is allowed for a review, not for a general paper. For a review, that's allowed. That means the figure is not independent. You read the figure, oh, I go back and read again. So there are trouble everywhere. But this is general principle. If you can follow this, then it's okay. No problem. Yeah, each figure is independent. What you see, you write. What you see, you write. And it has to be independent. If you have acronyms, define and use. Clear, right? Remember this, because when you will be writing, you will be making these mistakes. So remember this, okay? Okay, thank you.